All right, looking at worksheet 10. Okay, remember we're going to talk about our perfect squares. I will use my perfect squares on each one of these as long as I can, and then I will also try to go down and show you further on the smartboard where you can do it without using your perfect squares. For instance, if you chose to do the factor tree. All right, so for problem number 1, for 18, I'm going to choose 9 times 2. 9 is a perfect square. Its square root will be 3, so the 3 comes out and the 2 stays in. Don't forget to bring down your 7, and 7 times 3 is going to give you 21. Okay, going over to problem number 2. For 20, my perfect square that I'm going to use is going to be 4. 4 times 5. The square root of 4 is 2, so the 2 comes out, the 5 stays in. Bring down your 3, and 3 times 2 is going to give you 6. All right, and then number 3, for 27, perfect squares, I would use 9 and 3. Square root of 9 is 3, so the 3 comes out, the other 3 stays in. Bring down your 5, and that's going to give you 15 radical 3. Okay, so that's those 3 problems using my perfect squares. I'm going to clear my board now, and I'm going to show you just using a factor tree the same way that you would do these problems. Okay, so for 18, you might have chosen 6 and 3. Well, you'll break 6 down again into 3 and 2, and bring down your 3. Okay, this is all still under the radical. Okay, you have a pair of 3's here, so that 3 would come out, that 2 would stay in, and you'd still bring down your 7. Okay, for 20, you might have chosen 2 and 10. 10 is going to break down into 2 and 5. We've got a pair of 2's here, so that 2 would come out, the 5 would stay in, you still bring down your 3, and that still gives you 6 radical 5. And then for 27, you can only use 9 and 3, but 9 you might not have recognized was a perfect square, so you didn't pull that out, so you got 3 times 3. Again, there's a pair of 3's, and bring down your 5, and you still get 15 radical 3. Okay, so that's 1, 2, and 3 have been done using perfect squares, which is my preferred method, but also using a factor tree. All right, so for number 4, 40, perfect squares, I'm going to use 4 and 10. The square root of 4 is 2. 10 stays inside. Bring down your 6, which gives you 12 radical 10. Perfect square for 28 is going to be 4 and 7. Square root of 4 is 2. 7 on the inside, and 2 times 9 gives me 18. Okay, so there's 4 and 5 using your perfect square method. I'm going to go back and do the factor tree method in just a second. Okay, so if I did the factor tree with 40, I might start with 2 and 20. 20 is going to be 2 and 10, and 10 is going to be 2 and 5, so bring these down. Pair of 2's. These are left over, so that's 2 radical 10. Bring down your 6, and you still get 12 radical 10. And same thing with 28. You might have started with 2 and 14 and 2 and 7. So there's my pair of 2's. Times 9 is going to give me 18 radical 7. Okay, and then I'm going to jump to problem number 13. The remainder of those, 6 through 12, are the same way I did 1 through 5, just different numbers inside the radical. None of those are perfect squares, so they will all need to be broken down. All right, we're going to start by distributing here. All right, and then we're going to start moving. So I'm going to move the negative 2w over. It's going to become a positive Move the positive 14 over, it's going to become a negative. So 5W is going to be less than 40. Last step is to divide by 5, and W will be less than 8. You'll do the same types of steps for problem number 14. You do have an inequality quiz tomorrow. And if you will write your perfect squares, 1 through 20, on the back side of your homework twice, I will add some extra points to your quiz tomorrow. It's got to go all the way down through 20.